Hey, so today we're talking about how to graph rational functions. So if you notice, I have this graph right here, y equals 3 over x. This is a rational function because rational means fraction, and there's clearly a fraction in that equation. The function is nonlinear, so here's a picture of what the graph would look like. And notice it's not linear, it doesn't form a straight line. It actually looks kind of weird, and we'll talk about why it's kind of separated like that. Um, Notice that there's an x in my denominator. This tells me that it is also an inverse variation function. So just something to know. We talked about inverse variation yesterday when x was in the denominator, and this happens to be that case. Now in math, you can't do a number divided by 0. So if I did 3 over 0, you can't do that. It's not going to work. If you put it in the calculator, you're going to get an error. So since you can't divide by 0, we can't just plug in any number into our table when we figure out how to graph this, because if I plug in 0, it's not going to work. So 0 in this case is undefined because we can't do it. So any value of the variable that would cause the denominator to be 0 is called an excluded value. So we cannot have the denominator equaling 0. So whatever number that happens to be when you plug in a number into the equation, you cannot get 0 in the denominator. To find these excluded values that we can't have, you just set the denominator equal to 0 and solve it. So the first 3 questions, that's all we're doing. So I'm going to take my denominator, which was x, and put it equal to 0. Now there's nothing to solve there, so this is my answer. So in this case, x can't equal 0, which means I can't do x equals 0 on my graph. If I do number 2, I'm going to do the same thing. Take your denominator, x plus 1, put it equal to 0, so we get x equals negative 1. So in this case, x can't equal negative 1, because if it did, I'd get 0 in the denominator. Number 3, do the same thing. Take your denominator, put it equal to 0, and solve it. So I'm going to add 8 to the other side to get 4x equals 8. Divide by 4 to get x equals 2. So in this case, x can't equal 2, because if it is, and I plug it in, I'm going to get 0 in the denominator, which again, you cannot have. Looking at the graph above, you'll notice that the graph approaches but never actually touches the x and y axis. These are called asymptotes. So an asymptote is just a line on the graph that the function can never ever touch or cross. It's just going to get close to it. So we have vertical asymptotes and horizontal asymptotes, because if you notice in this graph, in this graph, it never touches this y-axis, so that's the vertical asymptote, and it never touches the x-axis, so that's the horizontal asymptote. So to find your asymptotes, I made it very clear in these little star points. The vertical asymptote is the excluded value, which you find again just by setting the denominator equal to 0. The horizontal asymptote is just the term that is being added or subtracted at the end of the equation. So it's kind of like your y-intercept that you're used to with slope-intercept form. So for number 1, I'm going to first find the vertical asymptote. So again, find the vertical asymptote by taking your denominator, putting it equal to 0, so x equals 0. So I'm going to find when is x equals 0, that's right here. That's vertical, so I need my dotted line to be vertical, it's going up and down. So my graph won't be able to cross this line. My horizontal asymptote is this number that's being added or subtracted on the outside, so that's negative 4, so y equals negative 4. So find y equals negative 4 right here. Since that's horizontal, it's going to go horizontally, left and right. Okay, so I have my vertical asymptote, my horizontal asymptote, and my graph will not be able to cross those 2 dotted lines. So from here I'm going to make a t-chart. Now you want to be careful with this. We're going to pick 2 numbers to the left of my vertical line and 2 numbers to the right of my vertical line. So my vertical line is at 0, so I can pick negative 2 and negative 1. And then again, it's at 0, so 2 points to the right would be 1 and 2. We don't want to include 0 because then I have 0 in the denominator and can't do that. So if I plug in negative 2 to my equation, 2 divided by negative 2 is negative 1. Negative 1 minus 4 is negative 5. Plug in negative 1. 2 divided by negative 1 is negative 2. Negative 2 minus 4, negative 6. Plug in 1. 2 over 1 is 2. 2 minus 4, negative 2. Plug in 2. 2 divided by 2 is 1. 1 minus 4, negative 3. So I'm going to plot those points, negative 2, negative 5, negative 1, negative 6, 1, negative 2, and 2, negative 3. Now when I connect these points, I'm going to start with this bottom left corner. We're going to get close to my asymptote but never actually touch it, and it's going to create a curve and then get close to my other asymptote and make some arrows. Same thing over here. I'm going to get close to my asymptote and then connect the dots. Okay, and then the next problem, I'm going to do the vertical asymptote again. So I'll set my denominator equal to 0, so x plus 1 equals 0, and solve to get x equals negative 1. So I have x equals negative 1, that's vertical, so it's going up and down. And then my horizontal asymptote is the number that's being added or subtracted, but there's nothing there. So that's y equals 0. So go to y equals 0, and that's horizontal, so it goes left and right. And then make your t-chart. So I want two numbers to the left of my vertical asymptote and two numbers to the right. So my vertical asymptote is at negative 1, so two numbers to the left would be negative 3 and negative 2. Two numbers to the right would be 0 and 1. Plug in negative 3. Negative 3 plus 1 is negative 2. 1 over negative 2 is negative 0.5. Plug in negative 2. Negative 2 plus 1 is negative 1. 1 over negative 1 is negative 1. Plug in 0. 0 plus 1 is 1. 1 over 1 is 1. Plug in 1. 1 plus 1 is 2. 1 over 2 is 0.5. Then graph it. Negative 3, negative 0.5 would be about here. So right where that negative 3 is. Negative 2, negative 1. I'm going to go ahead and connect those. So I'm going to get close to my asymptote, connect my dots, and then get close to my other asymptote. And then I have a point at 0, 1, and 1.5. Get close to your asymptote, connect the dots, and close to your other asymptote. And you're done. So I think you have 5 questions on your homework. The first 3 are like the first 3 in our notes, and then the next 2, which is on the back of the page, is just like these 2 graphs. If you have any questions, please let me know.